My name is Evelyn Gonzalez from Atos, and I am responsible of the Impact Dissemination and Communication Work Packet of DITAS project. This project is about data-intensive applications improvement by moving data and computation in mixed cloud and cloud environments. But well, in another part of this webinar, Enrique, that is the project coordinator, will give an overview of the project. So now I will focus on what are the DITAS webinar series. DITAS Consortium has organized a series of 2 webinars for end users to learn more about the technologies developed within the DITAS project and implemented in the 2 project use cases. The first webinar was held in July, and it was focused on Industry 4.0 use case. Within that use case, DITAS demonstrate how it is easy to develop, deploy, and maintain applications able to manage the significant amount of data produced by sensor and actuators installed on manufacturing plants. And in the second webinar, that is now, it's going to be focused on e-health use case. Within this use case, DITAS shows the possibility to easily develop applications able to process and to move clinical data from the premises to the cloud environment while ensuring the compliance with the published data, especially with the security and privacy issues. Please visit our YouTube channel for both webinars. That this webinar will be uploaded tomorrow. You can see the previous webinar in our YouTube channel. So in this webinar, Hospital San Rafael, partner of DITAS Consortium, is one of the leading prize scientific research institutes in Italy, recognized by the Italian Ministry of Health as a research hospital. OSR leads this use case and will present the current barriers and challenges that e-health sector faces nowadays and how DITAS outcomes can help to address them. One moment, okay. Before starting this webinar, let me introduce the speakers. Enrique Pages is DITAS project coordinator, and he has more than 12 years of experience in national and European research projects under different research topics such as grid computing, service-oriented architectures, virtualization, cloud computing, energy efficiency in data centers, and currently he is a technical leader of several IT research and innovation initiatives in Atos, Spain. Pierluigi Plevani is assistant professor at Politecnico di Milano, and he is the scientific coordinator of DITAS, where in particular he is currently investigating the role of the data movement guide by a goal-based model. Pierluigi is author of more than 70 journal and conference papers, and he has been involved in many Italian and European projects. His research is currently mainly focused on information logistics, info computing, and the adoption of IoT in business process management. From Ospedale San Rafael, the speakers will be Andrea Micheletti, that is responsible of the DITAS e-health use case. He is researcher in the e-service for life and health research unit of OSR, and he is currently involved in different European, national, and local research projects, and he's particularly focused on aspects such as business process, analysis, and reengineering. Since 2011, he's also in staff to the San Rafael Hospital Medic Direction Quality Department. And Ilio Catalo is a research fellow at the Center for Advanced Technology in Health and Well-being of Ospedale San Rafael, and he's responsible for overseeing all of the software development initiatives of the center, including the DITAS e-health demonstrators. So, well, this is the agenda for this webinar. It will consist in three main parts: an introduction to DITAS project that will be led by and presented by Enrique. Pierluigi Prevani will introduce the DITAS outcomes, and finally Andrea Micheletti and Ilio Catalo will present the health use case and will present the Ospedale San Rafael. We will end this webinar with a question and answer round. So let me give the floor to Enrique, and well, let's start.
Thank you, Nabelen. So Nabelen already told you, my name is Enrique Pages. I'm DITAS project coordinator. First of all, and very briefly, I would like you to introduce DITAS project. If you can go to the next slide, Belen.
Okay. Okay, sorry.
Yeah, DITAS is a research and innovation action project funded by the European Commission in the 2016 call under the cloud computing topic. DITAS is a 3 years project which main goal is to investigate how to better handle data-intensive applications on top of cloud and fog environments. And the project is focused on two main research challenges related with data and computation movement across these mixed computing environments that we just mentioned. In the next slide, we show the different organizations involved in the project. DITAS is composed of 8 partners from 5 different European countries: Spain, Italy, Germany, Greece, and Switzerland, and an associate one, Israel, representing South and Central Europe. This project is well balanced between academia and industry partners. From the industry side, 2 big players such as Atos and IBM are involved in the project. On the other side, from the academic perspective, we have several universities and research institutions, such as Polimi University Politecnico of Milano, Technical University of Berlin, for instance, as well, the ICCS Institute in Greece. And additionally, we have 2 final users who bring real use cases for validating the findings of the projects. IDECO from the Basque country, who provides an Industry 4.0 use case, and Ospedale San Raffaele in Italy, who provide a use case on e-health sector. You will get more details about this one across this presentation today, and the one and the use case developed by IDECO, you can check it in our website in the previous webinar that we record. In the next slide, I would like to highlight very briefly the objectives that the projects want to achieve. First of all, improvement of the productivity when developing and deploying data-intensive applications, enhancing the data management in mixed cloud fog environments, adding data and computation movement capabilities to the applications, definition of strategies for improving the execution of data-intensive applications, taking into account the security policies and being compliant with the different regulations, offering as well a set of tools for enabling the execution of data-intensive application in mixed cloud fog environments, and last but not least, maximize the impact on the business side. We are going to do that through the validation of our findings on top of 2 real use cases. As I already say, an Industry 4.0 use case and a health use case. The next slide show where we are in the project now. As you can see, this roadmap, the project starts with a design and specification phase that produces the design of the DITAS architecture that we release early in the project. And this also produced the detailed components specification. After this initial phase, the project was divided in 2 major development cycles. One finishing on month 18, where we released the first version of the DITAS platform, and the other and the other one finished on month 30, delivering the final version of DITAS. We are now in the last phase of the project, where the main tasks are the verification and validation of the solution, which is performed by your use cases and also the exploitation of the project results at the end of the project. The next slide, this figure depicts the different actors that could be interested in DITAS findings, the target audience for DITAS. We divide them in 3 different categories, as you can see in this picture, and among them we can find application developers, software architects, software integrators, which are involved in the development of data-intensive applications. On other side, we have data source owners and data analytics that wants to offer data in secure and reliable manner through our platform. Also, hardware vendors such as IoT providers to enable them the benefits of the edge adoption. And finally, cloud or edge providers, as well as independent software vendors that would like to integrate their offering with your solution. Finally, in my last slide, I would like to highlight some of the achievements of the project during this period. I will go through them quite quickly, as them are going to be covered with more detail during the next slides. As part of the DITAS solutions, we are offering a way to define what we call in DITAS VDC, which offers an uniform interface to access the data and defining the data and computation movement strategies to be applied. We release as well an SDK which supports the creation of these aforementioned VDCs, and also a set of software components that compose the DITAS execution environment. These software models are released as an open source, and they are already accessible from our public GitHub repository. Finally, we produce several press release reports and research papers that you can find also in our website. So I encourage you to check our websites for further information about our achievements and our releases. And that's all from my side. Now I will give the floor to my colleague, Dr. Plevani, who is going to cover in more detail the DITAS outcomes.
Okay, thank you, Enrique, for your presentation of the project. It's useful to present the project and to know what we are doing. And now I think that Pierluigi is going to share his screen. I'll give him the floor. And he's going to present in more technical details the project outcomes. So, Pierluigi, I think that now you can share your screen.
Yes, exactly. Can you see the screen?
Okay. Yes. Okay, perfect.
Thank you very much, Ana Belén, and thank you very much, Eric, for the introduction. Eric has already introduced the main objectives of DITAS, but in details. But if you would like to summarize a little bit, which is the main outcome of the project, we can summarize in these 3 main statements. So the idea is to provide an SDK that makes the life easier for the developer when developing data-intensive application. This is possible introducing the concept of virtual data containers that is quite crucial inside the DITAS framework. And these virtual data containers is the mean to make possible the data and computation movement in a fog computing environment. I would like, first of all, to introduce a little bit what do we mean with data-intensive application in our context. We have, this is a typical example in a Industry 4.0 scenario where we have machineries where some sensors are embedded and are able to collect data about the status of some process, and this information, this data can be analyzed by an application. This application can perform very quick analysis on these data streams that are coming from the infrastructure, the manufacturing plant infrastructure, in order to create a set of indexes, summarized data that can be used by other applications in order to be presented to the final users. In this scenario, and using the terms that we are using inside the DITAS project, we assume that we have a data administrator. What do we mean is a data administrator that is the person in charge of, let's say, managing the data in the manufacturing plant. This is not a physical actor, we say, a role that we have in our organization. He is in charge of the data collection. And we have an application developer that, based on the data that are made available by the data administrator, is able to create an application that is in charge of analyzing the data. And then we have what we call the application designer, that is the person in charge of consuming this, the result of this analysis in order to create one or more applications based on that. In this case, when we are talking about data streams, the typical situation is that we have that the data are generated usually on the edge of the network. This is represented by the ground at the bottom of the slide. And but usually the analysis is performed on the cloud, because the cloud has more capacity in terms of computation and storage. This is why we need to move the data from the edge to the cloud in order to be processed. And the application designer will need to have, especially in the mobile applications, to have the result to be transmitted to the ground, so to the edge again. This typical pattern has some drawbacks. Very quickly, first of all, we have at the edge a problem of capacity that is limited to the amount of mass storage that can be managed by the edge devices. Secondly, we have the big problem of latency introduced by the network that connects the edge with the cloud. And third, we have a problem of reusability, because usually these applications are computed, are developed for specific set of final users. So the application developer has to create different types of analysis for different type of users. This is a typical scenario with the data streams. We have another typical scenario which we are interested more today, because we are talking about e-health, about the data batch. It means that there are a lot of organizations that actually they are not collecting the data continuously, but they have already on their own premises or stored on the cloud a big amount of data that are collected in the past, and they know, since now we know that the data is the new oil, they have in some way to analyze in order to produce some information that can be used externally to the organization or even internally. Using the same icons that we introduced before for the other example, we have again the data administrator, the developer, and the application designer. In this case, a typical scenario includes the cloud as a way to store this information, this data, from made available to the data administrator. On the other side, again, the cloud would be used to process this data due to their huge capacity in terms of computation. And lastly, we have the application designer that needs the result of the analysis to the edge in order to be presented to the final user. Again, also in this case, we have other types of drawbacks. We have, again, the problem of reusability. We have, again, the problem of latency. But also we have problems in terms of privacy, because even if we have data from cloud to cloud, and the connection between the cloud to cloud could be optimized, probably managed by the same cloud providers, we are not sure that the data will be moved to a cloud in the same country or in the same jurisdiction realm as the first one. So we need to enforce a privacy control. especially now in Europe, because the GDPR is now is in place and we need to be compliant with it. The idea in DITAS is to exploit the fog computing. Fog computing, in the previous example, I was focusing only on the edge and on the cloud. That are two terms that are quite now common in the literature and the community. What we would like to use is the fog computing that can be defined as a place in between the edge and the cloud in order to create a continuum between these two environments. In this way, we can mediate between the scalability that the cloud offers and the reduced latency that actually computing the data on the cloud can be offered. So this idea is the idea in DITAS is to exploit along with the content delivery network principles and the service-oriented architecture design principles, to exploit these principles in order to create a data-intensive applications in which we are able to enhance the data management, also considering not only the quality of service, but also the data quality. So it means that we need to mediate between the responsiveness of our applications in terms of analytics. That could be also imprecise, but can be quicker, or we would like to have give to the application more time, but we would like to have a better quality of the data. Secondly, we would like to ensure mainly the privacy of our data, to enforce the privacy of the data in every place that can be stored, the data that we are managing. And thirdly, we would like to reduce the latency. In particular, in order to achieve these three main objectives, we have here represented the idea of having the data that we are generating and the application. We enclose these two elements inside one box that is a managed container. Managed means that these applications are monitored and can be self-adaptive. And having a managed container that at the end, technically speaking, we are using Docker in order to make this available, we can have, first of all, the advantage of being a platform independent. So it means that our container can be deployed either in the fog, in the cloud, or on the edge without any problem. This is in order to simplify the life of the developer. Secondly, we would like to, it is able, using a REST API interface, an interface that is context independent in order to improve also the possibility of reusing the application. So in this way, we are able to exploit especially the service-oriented architecture paradigm and the fog paradigm in order to have an element that is managed container that is able to be self-consistent and be able to also to move from the cloud to the edge and also to the fog. This is the main idea behind what we call the virtual data container. In particular, the virtual data container is composed of two main parts, the data access layer at the bottom and the data processing layer on the top. So the data accessing layer is the layer in charge of creating, enforcing the privacy. There is a specific component that is called Privacy Enforcement Engine that is able to control all the queries done against our data source in order to check if the request has the right to see the data, then all the data will be transmitted. Otherwise, the data could be blocked in case there's no rights, or otherwise can be anonymized or pseudo-anonymized according to the level of privacy that we agree to have on the other side. So in this way, we have these two elements that are able to achieve the three main objectives that we saw before. First of all, we have inside the virtual data container the so-called data utility evaluator. That is an element that, based on the data, on the status of the data coming from the monitoring system that is reading the status of our application, our analysis, and the data transmitted, is able to evaluate the data quality and also looking to the interaction with the final user, the application, we are able also to estimate the quality of service. In this way, we have a clear idea of what we call the data utility. Data utility, that is an element that is used by the data application in order to understand if the data are useful, considering not only the quality of service, but also the quality of data. Secondly, using the privacy enforcement engine, as I anticipated before, we have a component that is able to enforce the privacy with respect to the specific user that is accessing to the application. Third, in order to reduce the latency, we have the ability to move either the computation or the data, or even both of them, in order to move the computation or the data closer to where they are generated or where they are used, in order to have better performances. In particular, what we are offering in DITAS are two main elements. That is a software development kit and an execution environment. This is generally speaking the two main offerings of DITAS. About the SDK, what we have is that once the data administrator along with the application developer are able to define the virtual data container, they describe this virtual data container using what we call the virtual data container blueprint. And we offer a registry that is able to host the publication of these virtual VDC blueprints. In this way, having a registry, we allow an application designer to retrieve the most suitable blueprint connected to a VDC that is satisfying his requirements, not only with respect to the context of the data that they need, but also with respect to the data quality, to the data utility, so data quality plus quality of service. The VDC blueprint registry is able to return the list of blueprints that they are similar to the request, and then the application designer will select the best one, and this best one will contains all the recipe in order to make possible the deployment on the execution environment. So at this time we are on the design side, design time. At runtime, what is happening is that the execution environment through a deployment engine is able to understand, given the set of resources that could be available either in the fog or in the cloud or in the edge, which is the best place where to deploy the system. In this case, the system decides to be on the edge side, but the mechanism provided by DITAS in the execution environment also allows the system to automatically detect if there are some problems in terms of quality of service offered that could be misaligned between what has been promised when the application designer selects that specific VDC blueprint, and in this case to automatically decide to move either the data or the application, or even both of them, to another place closer to the other system. For the computation movement, we exploited the facilities provided by Kubernetes because everything is deployed on Kubernetes clusters. We are able to move containers between different clusters. For the data movement, we have proposed a hybrid method that combines the advantages of the physical copies and the logical copy of databases in order to have the possibility to move data faster without any type of locking and totally transparent with respect to the final user. This concludes my presentation. I gave you just an overview of all the techniques and the objectives. And I think that there will, in the next presentation, these concepts will be better described in the focus of the eHealth case study.
Okay,
thank you very much.
Thank you very much, Pierluigi. And now we are going to give the floor to Andrea Micheletti and Ilio Catallo from Ospedale San Rafael.
Okay. This presentation about the eHealth use case is constituted of these 4 parts. First, we have a presentation of our institution, Scientific Institute San Raffaele. Then we explain the use case scenario, and then use case application with details also regarding technical implementation. And then we have some remarks regarding conclusions. Scientific Institute San Raffaele is composed of these three main parts. First one is the hospital, where we have healthcare activities and also research activities. Then we have a foundation, Fondazione Centro San Raffaele, fully dedicated to research activities. And then we have also a university with teaching activity and research. From these slides, we see that research activity are spread all in these three main parts of our institution. Beside the hospital and university, we have an area of 74,000 square meters with also other kind of activities such as laboratories, offices, meeting rooms. We have varieties of shops, supermarkets, restaurants. We have also an hotel, sports ground. We have a shuttle monorail connected with the underground metro station, and we have also an energy-independent power plant on site. This is just to give an idea of the complexity of our institution. Every day here in San Raffaele, we have 25,000 people coming. These are patients, visitors, employees, students, and so on. This is just to show the map of our area. The yellow buildings, orange, green, and these are part of the hospital. Then the blue buildings and the building is dedicated to research and the university. Scientific Institute San Raffaele is part of the San Donato group that is composed of 18 hospitals, and San Raffaele is the biggest one. Okay, some details regarding specifically regarding the hospital. This was established in 1971 as a private provider of the Italian National Health Service. As I said, is extending an area with different facilities like a congress center, kindergarten, hotel, shopping gallery, and so on. And at the moment, San Raffaele has the highest scientific production among the research hospitals in Italy. Some snapshot regarding our hospital. We have 1,357 beds, over 6,000 employees, 50 clinical specialties. This means almost all the clinical specialties. We have 50,000 hospitalization every year, more or less 2 million outpatient activities, including blood tests and also other kind of performances. We have 67,000 access to the emergency department every year, and 25,000 surgical operation every year. And these are the number of hospitals in the category of the big hospitals. Regarding the research institution, okay, I mean the research activities that are spread all around the three different parts of San Raffaele Scientific Institution. We have 1,500 research workers. These are distributed in different divisions, research center, and institution. We have tenure researchers, tenure tracks, postdocs, pre-docs, also students from the university. An important aspect of our institution is we have also several clinicians that contribute to the research activities. Research, just to have an idea of our research division, we have neuroscience, immunology, genetics, oncology. Research center, we have the Advanced Technology in Health and Wellbeing Center. That is the center involved in the DITAS project. Then we have also other research institutes regarding gene therapy, neurology, diabetes, and urology. Regarding universities, it was established in 1996. We have three schools: the School of Medicine and Surgery, the School of Psychology, and the School of Philosophy. There is a strong integration between teaching, clinical activity, and both basic and clinical research. We have more or less 3,200 students, and we have also some qualified postgraduate education programs. Okay, now I want to show some ICT strategic goals of our institution, because these are important to understand the motivation for the selection of our specific DITAS health use case. San Raffaele is expanding in different directions these years, and the ICT must support this direction. OSR will be an hub of digital service for patients and their families. Research will continue to grow, and we'll need more data and services in the future. OSR will be a service center for the other hospitals of the San Donato group, as we have seen before. And we will develop synergies at the group level on logistics, disaster recovery, and security. And we are building a new part of the hospital with new operating theaters, with a new emergency department, and we've also with some new words regarding private patients. Okay, now we go through the use case scenario. San Raffaele Hospital, as many of the medium to big size hospital, is collecting in this year a significant amount of data with different types and formats. For example, we can mention that we have 15 terabytes every year of clinical imaging coming from magnetic resonance, computer tomography, and so on. We have personal data, clinical data, for example, blood tests and other type of medical tests. We have medical notes, medical report, and so on. Hospital, in general, hospital have the need and the obligation to securely store this data for a long period. And these data are mainly accessed when the patient is hospitalized, but when the patient leave the hospital, these are mainly not used, are used just in some occasions. For example, when the patient has some emergency events, or if he has to come back for follow-up visits. The resulting information heritage owned by hospital can constitute an invaluable source of information for other stakeholders working outside the hospital or even internal to the hospital. And for example, as we will see in our use case, these are useful for researchers because they can create benchmark, they can validate research study, to study healthcare outcome, to provide scientific evidence, and so on. And moreover, these data are also useful by other hospitals that have to care a patient primarily hospitalized in San Raffaele Hospital, because in many of the cases of the clinical practice, it's useful to have the patient's clinical history, because in this way we can have a better healthcare activity. So in this scenario, as we have seen before, cloud-based infrastructure represents the most suitable solution, because for the potential unlimited storage capacity and ease of reachability. The main issue that we have nowadays is regarding the privacy and security requirement, because as we have seen, these data are sensitive, so specific regulations such as European General Data Protection Regulation have to be strictly respected. This is an image of our in general of our scenario. Okay, we have considered two hospitals. The first one, that can be Hospital San Raffaele, and another one can be another hospital of the group or another site of the hospital. And the idea that we have the edge part constituted of server infrastructure and also the other mobile devices or workstation used by the medical doctor or other staff of the hospital. This data can be transferred to an hospital cloud, where this data can be stored for a long period. And then we have also added a research institution where we can have researchers that are employees of these hospitals, but also can be considered external researcher to this institution. And this research institution can use data coming from the hospital for research purposes. Obviously, as we have seen, we have to respect different regulations for privacy and security, but the idea is to move the data from the hospital cloud to the untrusted cloud, where this data can be taken by a research institution to perform research activities. So the idea is that the DITAS platform manages this data movement computation between cloud and edge in order to make available data to the different stakeholders. Okay, just I want to show some slides regarding regulatory requirements that we consider in our project. These are part of the European General Data Protection Regulation, and we can see that sensitive data, as we have, because this data regard the health status of the patient, can be used just for under some specific condition. The first one is the condition that the patient has to give consent for the use of the data. The second one is this data can be used if we have a vital interest of the person. Or the last possibility is to use this data for research activities. In this case, we have to respect other requirements that we will see in the next slide regarding, for example, anonymization or other security requirements. At the time of collecting data for treatment purposes in the hospital, the patient is permitted to express his content to some fields of scientific research. So in this case, this data can be used by research institution. Moreover, we have some requirements regarding the cloud service provider. The cloud service provider processor shall be governed by a contract. In this contract, we have to specify several activities to be performed. Among the other, we want to mention the measure regarding security. It has to be ensured in order to treat data coming from other for the hospital. Then we have requirement regarding how to use data by the researcher. In general, this data has to be anonymized, but in some cases, anonymization may reduce or even destroy the potential value of the data for the research activities. So in this case, the European Data Protection Regulation is opening a possibility to use pseudo-anonymized data. In this case, we want to highlight that the European member states are entitled to maintain or impose further conditions to these requirements. And in this year, Italy and also other European countries is going through a revision of the regulation, and probably we will have some difference among countries regarding the specific regulatory requirement. Then we have, in the regulation, we have also some, let's say, specific suggestions regarding data securities to be adopted in order to trade data. As we have said, we have seen, we have the pseudonymization, we have encryption of personal data. Then, for example, we have to assure the ability to restore the availability and access to personal data in a timely manner in the event of a physical or technical incident, and other kind of requirement. Okay, so now we go through the use case application. The DITAS use case is constituted by two distinct applications. The first one is regarding research activities. It's called Research App. This is a platform for the retrieval of research data. Primary user as the research internal to RSR. In addition, we decided to open this platform to external researchers, and they are restricted to anonymize the result set. In our use case, as we will see in the next slide, we have selected some representative queries to show how specific clinical data can be transformed so as to be usable by researchers. The second application is called Emergency Room App. It is intended for doctors operating in the emergency room department. It's proposed to provide a quick access to the entire history of clinical documents of a patient in the attempt of assisting the doctor when treating a patient in the emergency context. Okay, I want to show you some details regarding this last app. These are mainly the work that we have performed at the beginning of the DITAS project. We have selected a specific category of patient. These are patients with stroke. Stroke is a typical emergency situation. The motivation for this selection is because this is a relevant problem in terms of population public health. This because San Raffaele is also recognized as an excellence in this field. And also this process is involved with different types of healthcare data, so images, blood tests, and so on. We have studied the entire process of the patient within the hospital, starting from the emergency medical services, the emergency department, and also the other part, the acute unit ward, the rehabilitation unit, and the follow-up activities. In the DITAS project, we have considered in detail the emergency department. We have proceeded with some interview with doctors and informatics to the San Raffaele Hospital, and we have designed a model of this process. The goal of this activity was to study how the emergency room application designed developed in DITAS can help to improve the business process in terms of performance and also in terms of healthcare outcome for the patient. So we identified two parts of this process where the app can help the doctor and in general can help the activities within the hospital. Okay, now I leave the floor to William to show the technical implementation of this use case.
Yeah, so in this part of the presentation, I would like to discuss how the DITAS technology can help realizing the use case applications that we just presented. And we already saw how the VDC constitutes the cornerstone abstraction of the DITAS framework, in that it provides an abstraction for retrieving and processing data while guaranteeing the desired level of quality, privacy, data security, data protection, and obviously performance. So one important aspect, as was already discussed, of the VDC is that it is agnostic to the implementation programming language of choice. And we took advantage of this possibility by making different choices depending on the application that we had to develop. So for the case of the ER application, we decided to use Node.js as the development platform and to use Docker for containerization. But at the same time, for the research scenario, we decided that Scala and Apache Spark was the best choice for the job, and we kept using Docker for packaging. So the main job of the VDC, as we said, is to provide some methods that developers can use to retrieve data and defer to DITAS, the part related to data management. So in the case of the ER application, we designed 4 methods that we believe provide a good way for doctors to access the clinical history of a patient as quickly as possible. And specifically, we see that there is this get patient document list method that provides a fraction or even the entire clinical history of a patient depending on the search criteria of choice. So maybe in the case of a stroke, for instance, you may want to see the blood tests spanning a time frame starting from now to the previous 60 days. So you can do that by means of this method. In a similar fashion, we design, in the case of the research application, 2 methods, as many as the representative queries that we identified. And so we developed one first method named get blood test component average, which provides the blood test component, the average over a population of a given blood test component. And secondly, we also have this get nutritional data method, which provides nutritional related measurements always over a population. And these measurements comprise values such as the BMI and the cholesterol, which are useful for researchers to conduct their studies. So in doing so, we took advantage of the fact that DITAS provides some guarantees that are important to us. For one, policy enforcement, the fact that different users access data differently depending on their roles. So for instance, external researchers can access research data sets, but they are limited to anonymized data sets. And the second important aspect for us was the possibility of performing data movement. For instance, in the case of the research application, external institutions can get the data closer thanks to data movement if they are willing to invest some resources. And this is managed automatically by the DITAS framework. So once the development of the VDC is completed, it's up to the data administrator to make the VDC publicly available. And to do so, he has to prepare this mentioned VDC Blueprint, which is a JSON file containing crucial characteristics of the VDC. And this VDC has to be published to a blueprint registry or a blueprint repository, as we said, so that application designers can later decide if this is the best choice for the task at hand that they have to perform. So, which are the characteristics that are present into a VDC blueprint? Well, among other aspects, one of the most crucial information contained into the VDC is the definition of the data sources. In our case, we have relational and non-relational data sources. For instance, we use a relational data source when it comes to the demographics of the patients, but we use an object storage for storing the exams, for instance, for storing blood tests. So we have to specify exactly the nature of the data sources into the VDC blueprint. Of course, you find the definition of the VDC methods, such as get document list, get patient document list, as we saw before. And there is also some companion information related to supporting containers that we need to address cross-cutting concerns, such as authorization and authentications. We need to say where to fetch supporting systems for carrying out these cross-cutting concerns that we always need. So in this slide, we see a snippet of the VDC blueprint for the OSR use case. One important aspect to note is that data providers are not really meant to realize by hand this file. So they are assisted in the generation of this file, and this file is really meant to be consumed by applications. Still, given the fact that we decided to use JSON as the encoding mechanism, we see that even if we do a manual inspection, the VDC blueprint is quite human readable. For instance, we see that there is the definition of one of the methods that we mentioned, get blood test component average, followed by the definition of one other method, get nutritional data, followed by the definition of the data sources, and then many other sections follow. But still, even though you are not expected to go and see this file and edit this file by hand, it's still nice that you can, if you do so, you can still understand what's going on. So on the other hand, we have, as we said, application designers that need to select the best VDC blueprint for the job. In order to do so, they prepare another JSON file containing the application requirements that they would like to have for their applications, and submit these application requirements to the blueprint repository, to the blueprint registry. In there is a DITAS component called the resolution engine, which takes care of selecting the best blueprint for the job. So what's contained into this application requirement JSON file? Well, you find many aspects. Some of the most relevant ones are the response time, the expected response time for getting the data, other non-functional measurements such as the availability, security aspects, and many other functional and non-functional requirements that the application designer may have. So again, this is the application requirements file for our use case. This is a JSON file which is going to be automatically generated. So once again, the application designer is not really required to go and fill this stuff manually, but as before, as with the blueprint, it's quite human readable. So, for instance, we see here that there is a data utility measurement defined, so a requirement related to accuracy, and specifically, the application designer requires the accuracy to be at least 0.8, and many other data utility measurements can be defined in a similar way. So, once the most appropriate blueprint has been selected by way of an application requirements JSON file, the runtime part of the DITAS platform can, in fact, provision up and running VDC that application developers can later use to develop their application. The important aspect in here is that application developers are now free to focus on the relevant business logic of their application, rather than focusing on the business logic and other concerns related to data. They can defer all these aspects to DITAS and focus on what makes their application their application. So to make an example, in the case of the researcher application, application developers are really concerned about providing features such as the possibility of re-executing queries, the possibility of getting notified when new data sets are available, and this kind of stuff. And they can really defer all the other aspects related to data to DITAS. So with that, I conclude my part related to the technical discussion of the use case applications. I will leave the floor to Andrea for some final remarks. Thank you.
Okay. Regarding specific conclusion, we can say that the DITAS framework is facilitating the design and development of IT data-intensive application. In our specific use case, we mean this application to exchange health data with specific stakeholders such as researchers and medical doctors. In our case, this is enabling new digital services and new opportunities that we want to explore in this last part of the project with the exploitation activity. Moreover, the DITAS technological solution, with this solution, we have explored in terms of visibility, the possibility to offer data as a service to the identified stakeholders, respecting and be compliant with specific regulation mainly related to privacy and security issues. This is also an opportunity for exploitation activity that we are studying in this last month of the project. Okay, with this slide, we have finished our presentation.
Okay, thank you very much, Andrea and Elio. Now I'm going to share my screen, the presentations included in the DITAS webinar. And now we start a round of questions on answers. I don't know if there's anyone who has any questions for the speakers. No, everything is clear. Okay. Well, then, yes, thank you very much for joining this DITA webinar. Please visit our DITAS YouTube channel where we have another videos with a general vision of DITAS and videos of the other partners of the project, and visit our website and follow us in Twitter. Thank you very much, and join in our next exploitation activities. Thank you.